Good morning, students. Myself, Vijay Shankar from EC department at Chevrolet Engineering College. And today, we are going to discuss about the analysis of linear systems. There is a third unit for EC and fourth unit for the EEE students in the signals and systems subject. The topic is the analysis of a linear system. Okay, first of all, you can see what is a system, then what is a linear system, then we can analyze that linear system. See, in the analysis of the linear system, system means a system is a set of elements or functional blocks. A system is a set of elements or functional blocks that are connected together and produce an output in response to the input signal. Once again, I will explain what is the definition of the system. A system is a set of elements or functional blocks that are connected together and produce an output in the response to the input signal. This is a system. See the continuous time system and discrete time system. And it produces the output signal, the continuous time signal, in response to that of the input signal. It is a functional block here. A system is a set of element or a functional blocks that are connected together and produce an output signal in response to the input signal. So the classification of the system, there are two types of the systems, continuous time system and discrete time system. Signal is a different and the system is a different, my dear students. Until now, the 3 units we discussed about only on the signals only. Now it is a system. The subject name it as the signals and the systems. Signal is a different and the system is a different. Continuous time signal and the continuous time discrete time signal is different, but continuous time system and the discrete time system is different, my dear students. Be careful and listen carefully here. There are 2 types of the systems, continuous time system and the discrete time system. So what is a continuous time system? What is a continuous time system? A continuous time system handles continuous time signals. See, my dear students, here. Continuous time system handle continuous time signals. See, the continuous time system having the input is a continuous input signal and continuous output signal. Continuous time system handle continuous time signals. Analog filters, amplifiers, attenuators, analog transmitters and receivers are the examples of the continuous time system. The continuous time system is one type of the system. It handles continuous time signals. The examples are analog filters, amplifiers, attenuators, analog transmitters and receivers, etc. are the examples of the continuous time system. Coming to the second one, discrete time system. And this discrete time system is handled the discrete time signals shown in such a system here. The discrete time system handles the discrete time signals. The input, see here, the discrete time input signal, the output is a discrete output signal, y of n, x of t and y of t as a continuous, x of n, y of n as a discrete. Discrete time system handle discrete time signals, shows such a system in the figure B here. The computers, printers, microprocessors, memories, shift registers, etc. are the examples of the discrete time system. So whatever you know, the computer and the printers is all, it is a discrete only. And microprocessors, memories, shift registers, etc. are the examples of the discrete time system. They operate only on the discrete time signals. They operate only on the discrete time signals. Even if you given this continuous time signals also, it is internally converted to the analog to the discrete. Okay. Then after it performs the operation to get it is a response. Okay. There is a three different definitions of there here. What is a system? The system is a set of elements or functional blocks that are connected together and produce an output in response to the input signal. There are the two types of the systems. One is a continuous time system and the other one is a discrete time system. Continuous time system handle the continuous time signals and discrete time system handle the discrete time signals. The examples of the continuous time system is analog filters, amplifiers, attenuators, analog transmitters and the receivers. And the examples of the discrete time system, which is handles the discrete time signals, computers, printers, microprocessors, memories, shift registers, etc. And the discrete time system can operate only on the discrete time signals only. It does not take any continuous time signals. Understood? These are the two block diagrams of continuous time system with having the continuous time input signal and the response is continuous time output signal y of t. And discrete time system having the input is discrete time input signal x of n. And the response output is the discrete time output signal y of n. Okay, my dear students. And the next one, continuous as well as the discrete time systems. Continuous as well as discrete time system is again further classified based on their properties. We now discuss about what are the types of the systems, continuous and the discrete. And these two again further is classified as their based on the properties. 6 properties are there. The dynamicity property, nothing but static and dynamic systems. Shift invariance, nothing but the time invariant and the time variant systems. Linearity property, nothing but the linear and the non-linear systems. Causality property and causal and non-causal systems, my dear students. Linear signal and the non-linear signal is different. The linear and the non-linear system is different. And causal signal and causal system is different. Causal and non-causal system. Stability property, stable and unstable system. Invertibility property, inversible and non-inversible system. So you have to learn about the 6 different types of the properties that are classified of both the continuous and the discrete. Static dynamic systems, time invariant and time variant systems, linear and non-linear systems, causal and non-causal system, and the stable and the unstable system, and the last one is invertible and non-invertible system. The first one you can take the static and the dynamic system. Systems with memory or without memory. Static and the dynamic system. Definition of the static and dynamic system. See, the continuous time system is said to be static. A continuous time system is said to be static, or the static is nothing but it is a memoryless or instantaneous. A continuous time system is said to be static if its output depends upon the present input only. If its output depends upon the present input only. Remember, my dear students, it's very, very important. What is a static means? The continuous time system is said to be a static, or it is a memoryless or instantaneous, we can call it as. if its output depends upon the present input only. What is that present input means, sir? Present input. So input is always in the, see here, the block diagram showing that continuous time is x of t or x of n. For continuous is because we can denote it as x of t, and discrete time is denoted as x of n. The output is y of t and y of n. Okay. The continuous time system is said to be static or the memoryless and instantaneous if its output depends. So what is output here? Output is a y of t or y of n. Y of n. Okay, is a static and dynamic system is for both the continuous as well as the discrete time system, my students. But output is depends only on the present input only. Present means x of t, or in the discrete time x of n. If x of t is a present input, past input is x of t minus 1. Future input means x of t plus 1. Of it, the discrete x of n is the present input. X of n minus 1 is the past input. X of n plus 1 is a future input. Is a present in the discrete, and x of t is also the present in continuous. Okay. The static means the continuous time system is said to be static if its output depends upon the present input only. Then that system is static, otherwise it is a dynamic. Okay. Only if we have the output having the present inputs, then we can call it as a static. Otherwise it is a dynamic. The combination of the past and the present inputs, or the combination of the past and the future inputs, including with the present input also, we can call it as a dynamic system. Okay. So the discrete time system can also be static or the dynamic. If the output of the discrete time system depends upon the present input sample only, then it is called static or memoryless instantaneous system. For example, see, the y of n is equal to, in terms of x of n only, it is a multiplication factor, amplitude scaling, and y of n is equal to 15 into x square of n. X of n is nothing but present input, and x of n is also the present input. It's amplitude scaling of 10. A discrete time or it is a continuous time is said to be static if its output depends upon the present input only. The discrete time can also be static or dynamic if the output of the discrete time system depends upon the present input only. It is called static. It is called static only. Or the static system, here the y of n depends upon the nth input sample. Hence, such a system do not need memory for its operation. Why it needs a memory? If you can store the past input or it is a future inputs. It is only the present input, no need of the memory. It is a memoryless. No need to store the data. A system is said to be dynamic if the outputs depends upon past values of the input also. When we can call it as a dynamic, where it is not static. It is not static is a dynamic one. Nothing but in the mathematical equation, it is depends upon the past values. See here the present input is there, including with the past x of n minus 1. So y of n, this equation is a dynamic, and these two equations are the static equations, because the output y of n is depends upon the present inputs only. But in this equation is a dynamic. Dynamic system is, it is depends upon the present and also the past or the future. It needs a memory. The dynamic system needs a memory because it has to store the past inputs x of n minus 1 and the future inputs and the present inputs also. What is a static? Once again, I will tell. The continuous time system is said to be static if its output depends upon the present input only, or the output of the discrete. In the terms of discrete, if the output of the discrete time system depends upon the present input only, then it is called static or memoryless or instantaneous system. Okay. And for this system, so the system do not need memory for its operation. And what is a dynamic means? A system is said to be dynamic if the output depends upon the past values of the input also. The past values of input also. Past value. Y of n is equal to x of n plus x of n minus 1. Call it as a dynamic. Understood, my dear students? The first property, the dynamicity property in the linear systems. Okay, my dear students. Then you go for the second one, time invariant and time variant system. Time invariant and the time variant system. So time invariant and the time variant. First, you can see the definition of the time invariant means which is not the time invariant, it is a time variant. Okay. What is the definition saying here? A continuous time system is time invariant if the time shift in the input signals results in corresponding time shift in the output also. That is a time invariant. I will give the one example here, my dear students. The student wise, our college timings and the student. If the time, the actual time of the college is 9 o'clock, but the students enter due to some reasons, there is a traffic is there or whatever it is, the delay of the 30 minutes. Delay of the 30 minutes. Actually, the 9 o'clock is the time, college time to start the classes. There is a delay occurs due to some reasons. All the students came after the 30 minutes. After 30 minutes means 39:30. Actually, some of the students who are staying in the hostel, they are entered into the class. But due to some reasons, there is some students who are not entered the class or not entered to the college in time, but there is a late. But due to that reasons, we have not start the class at the 9:30 because already some students are there in the class. We started at our timings only the 9 o'clock. There is a shifting occurs. Shift means the 30 minutes delay is there. Shifted towards the right side. Delay. Shifted towards the left side is nothing but advance. Okay, my dear students. The output shifted even due to some reasons there. The students are not entered because already some students is there. The class is started at the 9:10 now. But we are not waiting up to the 9:30 of the remaining the students also. If the time is shifted, that is a time invariant. A continuous time system is a time invariant. If the time shift in the input signal means the students is delayed, in corresponding the time shifted in the output is the class timing is also the changes means that is a time invariant. You are not following as per the times. Time variant means as per only. The input is shifted, the output is also shifted, we can call it as a time invariant. Otherwise, if the input is shifted, the output is not the shifted means time variant. As per the time only the college is going on. Even the some reasons of the some students are not entered to the class, we are not bothering about that one. We are going to as per our timings only. Understood, my dear students? Okay, this is one example I am saying. If you are not understood, so leave it that one. But you have to see here, the input is shifted, the output is also shifted. Means input is x of t minus 1, the output is also the y of t minus 1. Shifting means we know the y of t is output, x of t is the input. Okay, x of t signal is passes through the system to get the response is y of t, a continuous time. If the input is shifted, the t minus the t naught samples, and it passes through the system, and output is also the shifted, the t minus the t naught, then we can call it as a time invariant. Time invariant. According to the input, the output is also shifted. Okay, if suppose in the discrete time n minus k given to the system, this system is a discrete time system. What is the y? The y of n minus k, the output is also shifted. A continuous time system is a time invariant if the time shift in the input signal, results in corresponding time shift in the output. Then that signal we can call that system, not the signal it is, that system we can call it as a time invariant system. If it is not, output is not shifted. So x of n minus k, the output is y of n only. And here the output is y of t only, means that system is a time variant. Time variant. Entered into the college with the time, or it is out of the time of the delay or advanced. As per our the times we are starting the classes. That is example simply. Okay. According to the input, the output is also changes, means the time invariant. According to the input, if the input is changes, the output is not at all changes, the same thing will get nothing but the time variant signals. See once again, a continuous time system is the time invariant if the time shift in the input signal results in corresponding the time shift in the output. Okay, you see here the y of t is equal to is a function of x of t. Why I am taking it as a function means it is passes, the x of t signal is passes through the system. That is, y of t is a response for x of t if x of t is delayed by the t1. X of is delayed by the t1, x of t minus t1, the y of t minus t1, y of t minus t1. The time variant system does not satisfy the above relation. The time variant system does not satisfy the above relation. The time invariant system is also called as fixed system, which is not satisfied, which is not equal to this condition, that we can call it as a time variant system, which is equal to the system is time invariant system. Okay. Similarly, if the input and output characteristics of the discrete time system do not change, the shift of the time origin, such systems are called shift invariant or time invariant system. Let us, the system has our input x of n and corresponding output is y of n. The y of n is a function of x of n. Then the system is shift invariant. Shift invariant. Here the time invariant I am calling. In the discrete we are saying shift invariant or time invariant if and only if the f of x of n minus k, the input is shifted, the output is also shifted here. The input is shifted, the output is also shifted, then we can call it as a time invariant or shifter invariant. If it does not satisfy, the relation, the function of x of t minus t1 is not equal to y of t minus t1, or the function of x of n minus k is not equal to y of n minus k, that system we can call it as a time variant system. Time variant system. Understood, my dear students? The second one, time variant and the time invariant, is a very important, because all the time in input system is a linear time invariant system only. That whatever the system we are taking to perform the operation on the input signals, to get the output response for the input signals, that system is always a linear time invariant system. We are adding that as a linear also, linear systems. That is the third one here. See, the linear and the non-linear systems. What is a linear system? A system is said to be linear if it satisfies the superposition principle. Everyone, you know, the IIIE students and the IIECE students, we already learned the network analysis. What is a superposition theorem? A system is said to be the linear if it satisfies the superposition principle. That is, consider the two systems defined as follows. Y1 of t is a function of x1 of t. That is, x1 of t is the input and the y1 of t is output, and y2 of t is a function of x2 of t. x2 of t is the input and the y2 of t is the output. Then the continuous time system is linear if the function of a1 x1 of t plus a2 x2 of t is equal to a1 y1 of t plus a2 y2 of t. Is we already learned in the properties of the Fourier series and the properties of the Fourier transformations, linearity property. Okay, the linearity property saying that x1 of t plus a2 x2 of t in the Fourier transform Fourier series a1 x1 of k plus a2 x2 of t. In the Fourier transformation a1 x1 of t plus a2 x2 of t can apply the Fourier transformation. Here the function is nothing but a Fourier transformation. What is the output here? a1 x1 of k and a2 x2 of t. x1 of k is output there as a frequency response. Now the output is a y1 of t, a1 y1 of t plus a2 y2 of t. Here a1 and a2 are the constant, arbitrary constants. This condition states that combined response due to the x1 of t and the x2 of t together is the same as sum of individual responses for the linear system. Individual responses for the linear system. I will explain in the block diagram, my dear students. See, the linear system is nothing but I'm taking the a1 and a2 is a multiplication factors. Input signal is x1 of t and another input signal is x2 of t. I'm giving to the system to get the response y1 of t is equal to a1 into x1 of t. a1 into is a function of x1 of t because it is transmitted to the system. And similarly, if I give in the another signal to the system to get the response is y2 of t, that is a2 into the function of x1 of t. Why I wrote that is a function means it is passes to the system. And these two signals we added here. These two signals we added to get the response is y of t. What is the y of t now? Y of t is equal to y1 of t plus y2 of t. nothing but a1 with the function of x1 of t, nothing but is the y1 of t, plus a2 into function of x2 of t. Okay, this total is equal to, when it is a linear, y of t is equal to y1 of t plus y2 of t is nothing but a1 a function of x1 of t and a2 function of x2 of t is equal to. Now I'm taking the same x1 of t with multiplying with a1 x1 of t and the x2 of t multiplying with a2. Before giving to the system, now I'm adding these two signals, nothing but a1 x1 of t plus a2 x2 of t. Then after you can give it to the system. Okay. Individually you can give the system also, you get the same response. After the getting of the two signals you can add. But here, before giving to the system, add the two signals a1 x1 of t and a2 x2 of t. To get the response is y of t is equal to, is a function of a1 x1 of t plus a2 x2 of t. Okay, my dear students. Now I'm taking that as a into the function of x1 of t plus a2 into the function of x2 of t. So both are the same here. Individually given to the system or the individual signals added, after adding to that given to the system is both are the same, then that system you can call it as linear system. And the y of t here, and let us, this is the y dash of t. So y of t is equal to y dash of t. After adding the two signals given to the system or before adding to the signal given to the signal system, both are the same, then the system is said to be linear system. Otherwise, whatever we are getting the y of t from this block diagram and y dash of t we get from this block diagram, if both are equal, it is a linear. If not equal means a non-linear system. Non-linear system. Understood, my dear students? So that only we are explaining here by using the equations. y1 of t is a function of x1 of t and y2 of t is a function of x2 of t. And adding of the two functions here, the function of a1 x1 of t plus a2 x2 of t, to get the response is a1 y1 of t plus a2 y2 of t. This condition states that the combined response due to the x1 and x2 together is the same as sum of the individual responses. Okay, sum of the individual is same as the sum of the individual responses for the linear system. Understood, my dear students? Similarly, for the discrete time, instead of t, you can use here the n. y1 of n is equal to function of x1 of n. That is, x1 is the input and the y1 is the output. And y2 of n is equal to, is a function of x2 of n. That is, x2 of n is the input and y2 of n is output. The function of a1 x1 of n plus a2 x2 of n is equal to a1 y1 of n plus a2 y2 of n. What is a y1? Nothing but y1 of n is equal to, is a function of x1 of n with multiplying with a1 here. And what is a y2 of n? Is a function of x2 of n. Okay, why you are writing the function of the signal x1 of n is passes through the system. To get the response is y of n. So what is the response here? The function of x of n is equal to the function of x of n. In some textbooks we are writing as a t of x of n. Don't confuse. Okay. Some textbooks they are representing with the t of x of n when the signal is passes to the system. Whatever the signal, either it is a continuous time signal or discrete time signal representing of the T of X of n. Okay, my dear students. A system is said to be the linear if it satisfies the superposition principle. Individually, you can take it as, and that is also equal to after adding of the two signals given to the system. Individual system is passes to the system. After that, you can add the both signals. That is equal to, before sending to the signal to the system, you can add the two signals. Then after you can send through the system. Whatever the response we got, that response and to that response, the y of t is equal to y dash of t, both are equal, then the system is a linear system. Otherwise, non-linear system. Otherwise, it is a non-linear system. Understood, my dear students? Okay. Coming to the third one, till now we learn about what are the different types of classification of the further classification of the continuous and the discrete time systems. One is static and the dynamic system. Static means it depends upon the present input only. Okay. Otherwise, if it is depends upon the present and the past or the future, we can call it as a dynamic. Time invariant and the time variant. Time invariant means the input is delayed, the output is also delayed. If the time shift in the input signal results in corresponding the time shift in the output. Okay, otherwise it is a time variant system. Linear system. The system is said to be linear if it satisfies the superposition principle. Individually, the signal is passes to the system. The output responses you can add y to get the response y of t, or otherwise this is equal to the, before given to the system, the input two signals you can add before given to the signals system. That response is also equal, then that system is a linear system or otherwise non-linear system. Coming to the fourth one, causal and non-causal system. Causal and non-causal system. A system is said to be causal if its output, a system is said to be causal if its output at any time depends on, we already learned that is the first one is a static. If it depends upon the present input, it is a static. Here the causal system is, a system is said to be causal. A system is said to be causal if its output at any time depends upon present and past inputs only. Means it having, which is the dynamic is there, that is nothing but here the causal. Present and the past inputs, x of n and the x of n minus 1. Okay. The system is said to be the causal if its output at any time depends upon the present and the past inputs only. It is y of t is equal to, is a function of x of t. That x of t, can see the t is less than or equal to t naught. Equal to means is a present, less than means is a past. Okay. Thus, the output at any time t naught depends upon the inputs before t naught. The causal system is not anticipatory. Before, anticipatory means is a before it is. The causal system is not anticipatory. Similarly, a discrete time system is said to be causal if its output at any time, at any instant, depends upon the present and the past inputs only. See, the y of n is equal to the function of x of k. That k value is equal to n and the less than the n. Equal means x of n and less than means x of n minus k. Thus, the output function is x of n minus 1, n minus 2, n minus 3, and so on. For causal system, the system is non-causal if its output depends upon the future inputs also. You see here the x of n plus 1, n plus 2, n plus 3 with combination of this function, that system is a non-causal system. Okay, my dear students. Causal system is it depends upon the present and the past inputs, whichever we already discussed, the dynamic system. Okay, but it is depends upon the future input. Future input is a non-causal system, including with x of n also. X of n minus 1 plus x of n plus 1 is there. That system is non-causal system. Normally, all causal systems are physically realizable. There is no system which can generate the output for inputs which will be available in future. Such systems are non-causal and they are not physically realizable. Causal systems are physically realizable because it is not physically realizable or the non-causal systems. It depends upon the present and the past inputs, calling it as a causal systems, we can physically realizable. Which is depends upon the future input, which is not realizable, physically realizable, nothing but the non-causal systems. Non-causal system, my dear students. Okay. Now the fifth one. Coming to the fifth one, my dear students, here, stable and unstable systems. Stable and unstable systems. What is a stable system? When every, see here the definition, when every bounded input produces bounded output, BIBO, bounded input, bounded output. When every bounded input produces a bounded output, then the system is called bounded input, bounded output stable system. If input is stable, the output is also stable, then we can call it as a stable system. See, in the second one, the input is shifted, the output is also shifted, we can call it as a time invariant system. But here, the output is bounded, nothing but is a finite. Bounded means it's a finite limits. The input is bounded, the output is also bounded, means the input we can take the finite value, the output is also the finite, then we can call it as a stable system. If you take the input is a finite, the bounded, the output is not bounded, nothing but is infinite. Infinite, we can call it as unstable system. This criteria is applicable for both continuous and the discrete time system. The input is said to be bounded if there exists some finite number. Bounded means some finite number, nothing but mx, m suffix x, such that for continuous time system, the x of t is less than or equal to mx less than the infinite. Okay, less than the infinite is nothing but is a finite number only. Discrete time also less than the infinite. The magnitude of x of n is less than or equal to mx less than infinite. Similarly, the output is said to be bounded if there exists some finite number, not infinite, some finite. Bounded means it having the value is a finite one. If the input is bounded, the output is also bounded, we can call it as a stable system. See, for continuous, y of t is less than or equal to my less than the infinite. Mx is a stable system. Input is stable here. The output is also stable. The discrete time system, y of n is less than or equal to my less than infinite. Here it is a finite value. Mx is a finite number. My is also the finite number. Then we can call it as a stable system. If the system produces unbounded or bounded input, then it is called unstable. If the system produces unbounded output for bounded inputs. Means it is a mx. The output is my is equal to, it's not the my is nothing but the finite number. The output is infinite for the input of a finite number, then it is unstable system. Okay, my dear students. The input is bounded, the output is also bounded, call it as stable. Input is bounded, but output is unbounded, call it as unstable system. Unstable system. The fifth one. Okay. And coming to the last, sixth one, the classification, invertibility and inverse system. Invertibility and inverse system. A system is said to be invertible, means inverse, if there is unique output for every unique input. A system is said to be invertible if there is unique output for every unique input. For every unique input, there is a unique output we have. That system is called it as an invertible system or invertibility. The concept here, the input I am taking the continuous time signal x of t, given to the system, getting the response is y of t. And the y of t, now the input to the inverse system, invertibility, inverse system. Finally, again, it is a y of t, x of t on. Like that, we know involution law, x bar whole bar is equal to, the STLD we already seen, x bar whole bar. X of t, the system will get the y of t, and again it is an inverse for the system and inverse. So H is a system, let us say H inverse is the inverse system. H into H inverse is nothing but again the input signal only. There is no any system here. Directly whatever the input is there, the output is the same, y of x of t only. Okay. If the system is invertible, there exists an inverse system. If these two systems are cascaded, see here the cascaded, as shown in the figure, the final output is same as the input. If the system is invertible, there exists an inverse system. Fourier transformation, inverse Fourier transformation. Finally, again, we'll get the same x of t on. Okay. Suppose x of t, the Fourier transformation. What is the Fourier transformation? You get the x of omega. For the x of omega, again you can apply the inverse Fourier transformation of this one to get the x of t. See the x of t and x of t. Here the system I am using, here the inverse system. So if the system is invertible, there exists an inverse system. There exists an inverse system. If these two systems are cascaded, system and inverse system, the final output is same as input. The final output is same as input. If the system denoted by the H, the system denoted by H, and its inverse system is denoted by H inverse, then cascading of the two systems H into H inverse is equal to 1. H inverse and H inverse, H into H inverse is equal to 1. Means the system is nothing but is a 1 only. X of t into 1 is x of t. Okay, my dear students. So in the fourth chapter, till now we learn what is a system. A system is an interconnected components. The system is nothing but an element or interconnected components to perform the operation on the signal. To perform operation on the signal or the getting the output with response to the input signal. Okay. The system is said to be set of elements or the functional blocks that are connected together and produce an output in the response to the input signal. The system is two types, continuous time system and the discrete time system. Continuous time system handle continuous time signals. Examples are analog filters, amplifiers, attenuators, analog transmitters and the receivers. And discrete time systems handle the discrete time signals. Examples are the computers, printers, microprocessors, memory, shift registers, etc. And the discrete time system can only operate on the discrete time signals only. Okay. And the continuous and the discrete time systems are further classified on their properties. And 6 properties we have here: dynamicity property, shift invariance property, linearity property, causality property, stability property, and invertibility property. The first one, the static and the dynamic system. What is a static means? The continuous time system is said to be static. The continuous time system is said to be static, or it is a memoryless or instantaneous if its output depends upon the present input only. If its output depends upon the present input only. If it does not depends upon the present input, it is also depends upon the past values. Call it as dynamic system. Nothing but dynamicity property. Second one, the shift invariance property. The time invariant and the time variant system. What is a time invariant system means? A continuous time system is time invariant if the time shift in the input signal results in corresponding the time shift in the output signal. Results in output signal. Okay. If suppose the system is a time invariant or the time invariant, it does not satisfy the above relation. The input is delayed, the output is not delayed the function, then that system is time variant system. What is the equation? The function of x of t minus t1 is equal to y of t minus t1. And in the discrete time, the function of x of n minus k is equal to y of n minus k. And coming to the third one, the linear and the non-linear system. A system is said to be linear if it satisfies the superposition principle. Superposition principle, the sum of the individual. The condition states that the combined response due to the x1 and x2 together is the same as the sum of the individual responses. Combined responses due to the x1 and x2, what I explained in the block diagram, before giving to the system, the two signals are combined together is same as sum of the individual responses. Sum of the individual responses means individual response, the signal is given directly to the system and getting the response there. And another signal we are giving to the response to the signal to the system to get the response. And these two responses added, sum of the individual responses here. The sum of the individual responses is the same as the combined responses due to the x1 of t and the x2 of t. It satisfies the superposition principle, individual responses and the combined. Okay. If it satisfies, that system is a linear system. If it is not satisfied, non-linear system. What is a not satisfied means it's not equal to. And here also the discrete time function not equal to. It is not satisfies the linear system. Okay. Coming to the fourth one, causal and non-causal. What is a causal? A system is said to be causal if its output at any time depends upon the present and the past inputs, x of n and the x of n plus n minus 1. If it depends upon the future input, then it is called as a non-causal system. X of n, x of n minus 1, n minus 2, n minus 3, all it is combined, nothing but a causal. If any one input x of n plus 1 is there in the function, it is a non-causal system. Non-causal system. Coming to the fifth one, see the non-causal and the causal, normally all causal systems, causal system is present inputs and the past inputs it presents is physically realizable. There is no any system which can generate the output for inputs which will be available in the future. There is no any system which can generate the output for the inputs which will be available in future. Okay, it depends upon the past and the present means it is predictable. You can anticipate it. Okay, but which will be available in future, that systems are non-causal systems and they are not in the physically realizable. Which is physically realizable, call it as a causal system. Which is not physically realizable, we can call it as a non-causal. It depends upon the future inputs because it depends upon the future inputs. Coming to the stable and unstable system, for every bounded input produces a bounded output, then the system is called as BIBO, bounded input and the bounded output, a stable system. If the input a finite number mx, the output is also the finite number my, then that system we can call it as a stable system. If the input is bounded but the output is unbounded, nothing but infinite, call it as a unstable system. Call it as unstable system. Okay, my dear students. And coming to the last one, sixth one, invertibility and inverse system. A system is said to be invertible. A system is said to be invertible if there is unique output for every unique input. A system is said to be invertible if there is unique output for every unique input. Means the input is equal to the output is equal to the input only. And it is a concept shows that the input x of t given to the system to get the response y of t, and this output response y of t is given to the inverse system, and final output is the same as the input only. If the system is invertible, there exists an inverse system. If these two systems are cascaded as shown in the figure, then final output is same as the input. The final output is same as the input. If the system is denoted by H, then its inverse system is denoted by H inverse. Then cascading the two systems is given as a 1. H into H inverse is equal to 1. H into H inverse is equal to 1, my dear students. Okay. So in the today's class, we learn the continuous and discrete and further classified the systems. In the tomorrow class, you can see the frequency response of linear time invariant systems. Okay. So any doubts? Okay, my dear students, thank you.